Welcome back to physics online session. So in previous section we had been discussing on capacitance. So in case of that capacitance, so already we come to know that so capacitance is nothing but it measures that ability to hold the charges. So in case of that capacitance, already we come to know that capacitor. So in case of that capacitor, it is a device which can use to hold the large quantity of charges by less potential. So in order to hold the large quantity of charges, what should be the potential value here? Potential value should be less. So that device we will name it as a capacitor. So in case of that capacitor of an isolated spherical conductor, so in case of that a capacitance of an isolated spherical conductor, we got that mathematical expression. So that is C is equal to 4 pi epsilon naught into R. So if we calculate that radius of that spherical conductor, so that isolated sphere must have the radius 9 into 10 to the power of 6 kilometer. So this value is very much large. So in extent I said that so this radius of the sphere is around about 1500 times greater than the radius of the earth. So it means that practically it is impossible to conduct or practically it is impossible to consider that isolated spherical conductor. So it means that so capacitance, its SI unit is 1 farad. So in order to construct that capacitance as a 1 farad, so its radius value should be 9 into 10 to the power of 6 kilometer. So it means that so practically we can say that 1 farad is a large quantity, and one more thing, it is practically impossible to make that isolated spherical conductor. So for that purpose, now I will consider that two parallel plates. So two plates I will consider, and these two plates I will make it in a parallel arrangement. If I place that two plates in a parallel arrangement, what will be the value of capacitance I need to find out? So I will consider that capacitance of a parallel plate capacitors without dielectrics and with dielectrics. So there are two concepts. So already we discussed the concept related to dielectrics. So I will consider that two plates here, two plates I will place it in a parallel manner. If I place those two plates in a parallel manner, what will be its capacitance value I need to find out. So I will give that mathematical approach for capacitance of a parallel plate capacitor. So let me derive an expression for capacitance of a parallel plate capacitor. So derive an expression for capacitance of parallel plate capacitor. Parallel plate capacitor here. So for that purpose, so let me consider that two plates, and these two plates are placed parallel to each other. One is positively charged, other one will be negatively charged. So in case of capacitor, I said that what is the principle of capacitor? So in order to get that more charge on the capacitor, so I will consider one charged plate. Nearby the charged plate, if I take one uncharged plate here, so uncharged plate consists of positive and negative ion. Negative ion will accumulate at the inner side, whereas positive ion will accumulate at the outer side. If that outer side is ground one, so what happens here? One is positively charged plate, and inner surface of the uncharged body negative charged plate, means negatively charged ions will get formed here. So one is positive and another one will be negative here. Because of the positive and negative ions, so there exists a decrease in its potential. So if the potential is decreased now, so there exists a decrease in potential of the plate A. So in order to raise its potential, so I am having chance to add one more, or I am having chance to add some more electrons here. So if I add some more charges, means so what is the purpose of adding that here? So in case of capacitor, so it is a device which is used to store large charges in a low potential, I said. So I am having chance to store large number of charges. When there is a possibility of storing large number of charges, when the potential will get decreased. So now I decrease the potential because of one is positive, another one is negative. Here potential of the plate A is decreased now. So now I am having some more chance to add the charge particle here. So more number of charge particle is stored at plate A here. So now I will consider that two plate here, these two plates I will place it in a parallel manner. So look at here, one is plate A here, another one is plate B. So on that plate A, positive charges accumulate here, on the plate B here, where negative charges will get accumulate here. So look at here, on the plate A positive charges, on the plate B negative charges. So distance between these two plates I will take it as a d here. So distance between the plate A and plate B is d here. Area of the plate A and plate B will be same. So that area I will take it as a in generally A here. So area of the plate A and plate B will be A here. So now I will consider that, consider plate A and B. So these plates are oppositely charged, A and B were oppositely charged, where these two plates are oppositely charged, oppositely charged. So placed parallel to each other, 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 and separation between them is d. So let me write it here, and separation between them, so separation between them is d here. So what is the separation between these two plates here? Separation between the plate is d amount here. Now let me calculate that electric field due to plate A as well as electric field due to plate B. So I want to calculate that electric field between the plate A and plate B. So first let me find out that electric field between the plate A and B. So look at here, electric field, electric field between the plate, electric field between the plate A and B is, so I want to calculate that electric field between the plate A and as well as plate B. So for positive charge, what is the direction of electric field? So this is the direction of electric field. So this is the direction of electric field lines for a positive charge. For plate A, positive charge means electric field lines are outward here. So for plate B, so what is the direction here? So inward direction. So this is E of B here. So look at here. So for plate A, this is the direction of electric field lines. Why? Because for the positive charges, field lines are outward here. So for the negative charge, field lines are inward. Both are in the same direction here. So direction of electric field due to plate A and due to plate B is same here. So shall I take the total electric field E is equal to E of A plus E of B here? So look at here. So E is equal to what? E of A plus of E of B here. So hope you understand here. Next one. So in first chapter we derived the expression for that. So electric field due to uniformly charged infinite plane sheet. So hope you remember that equation. So electric field due to uniformly charged infinite plane sheet. So that equation is sigma divided by 2 epsilon naught. So once you open the notes, so from the first chapter, electric field due to uniformly charged infinite plane sheet. So that equation is sigma divided by 2 epsilon naught. So shall I write this equation as a sigma divided by 2 epsilon naught? This is also sigma divided by 2 epsilon naught. So here two plates are there. For single plate, what is the equation here? Sigma divided by 2 epsilon naught plus of sigma divided by 2 epsilon naught here. So hope you understand here. So next step. So 2 epsilon naught, if I take that LCM, sigma plus sigma, so that is 2 times of sigma here. So electric field E is equal to what? Sigma by epsilon naught, where sigma represents what? Sigma represents that surface charge density. So from that surface charge density is nothing but what? Charge per unit area. So shall I take this equation? For example, I will name this as a equation 1, where sigma is equal to what? So sigma, shall I take it as a Q by A here? So what's the equation? So sigma is equal to Q by A here. So sigma is equal to Q by A means in equation 1, wherever sigma is there, so I will fill it as a Q by A here. Then equation 1 becomes here. Then equation 1 becomes. So shall I rewrite this equation 1 here? So sigma is nothing but what? Q by A into epsilon naught term is there in denominator. We got that electric field here. So now I will find out that what's my intention here. So I'm going to be determined. So derive an expression for capacitance of parallel plate capacitor. What is the generalized equation for capacitance? So C is equal to Q by V here. So what's the generalized equation? C is equal to Q by V, or you can take this one as a capital, whatever. So C is equal to Q by V here. So in order to get that capacitance value, which value I need to find out here? Potential value. I got that electric field value. I know the relation between field and potential. So in terms of magnitude, E is equal to minus dV by dr. In terms of direction, in terms of magnitude, so simply I will take that E is equal to V by d. So we know the relation between field and potential. So now let me find out that potential value here. So look at here. So we know that so relation between field and potential, what's its value? We know that relation between field and potential, so shall I write this equation as a E is equal to V by d here in terms of magnitude. So E is equal to V by d. So I will rewrite this equation as V is equal to what? E into d. I will take this as a equation 3 here. So V is equal to what? V is equal to E into d here. So in equation 2, wherever E is there, so in equation 3, wherever E is there, shall I fill that one as a Q divided by A epsilon naught here? So look at here. So I will substitute, put equation 2 value in equation 3. So look at here. V is equal to Q divided by A into epsilon naught into d here. So this is the equation for the potential. So from capacitance, so finally from capacitance, I know the formula. C is equal to Q by V here. So I know the formula for capacitance. In last class I said that. So C is equal to Q by V here. So now look at here. Wherever V is there, shall I fill this value? So then, so I will substitute equation 4 value in equation 5. So let me fill it here. So C is equal to what? So Q divided by, so V means what? Q into D divided by epsilon naught into A. Q term will getting cancelled out here. Epsilon naught A term will goes to numerator. So finally what will be the equation here? So C is equal to epsilon naught A divided by D here. So what's that C value here? So capacitance of a parallel plate capacitor. So C is equal to epsilon naught A divided by D here. So this one is between the plate. So I will consider that air or vacuum here. So without dielectrics. So I am not placing any kind of dielectric medium between the plate A and plate B. If I place the dielectric medium, so formula will get differ. So now we'll look at next one. So first, so this equation C is equal to epsilon naught A divided by D. So this equation is without dielectrics. So without dielectric, or I will simply say in this situation air or vacuum is act as a dielectric medium here. So we are going to be derive the expression for capacitance of a parallel plate capacitor without dielectric, or I will simply call it as air is act as a dielectric medium. So for my convenience, just I will take it as a C naught here. So this one is C naught. That C naught means, so I will consider that equation as a capacitance of parallel plate capacitor without dielectrics. What's the final equation? I get it here. C naught is equal to epsilon naught A divided by D. So from this equation, what's the conclusion I need to give here? So in order to increase the capacitance value, so on what factor that capacitance of a parallel plate capacitor will get depends here. So in theory examination maximum time, so this equation they will ask for 3 marks. For 2 marks they will ask the question like so. So on what factors that capacitance of a parallel plate capacitor will depends here. So capacitance of a parallel plate capacitor is depends upon the area of the plate, and it is so directly proportional to area of the plate, and capacitance of parallel plate capacitor is inversely proportional to distance between the plate, and so capacitance of a parallel plate capacitor is depends upon that epsilon naught means what? Permittivity of the free space here. So look at here, capacitance of parallel plate capacitor is directly proportional to area of the plate, and it is inversely proportional to distance between the plate. So look at here, in order to increase the capacitance value, what suppose I have to do? I should decrease the distance between the plate. If I decrease the distance between the plate, its capacitance value will get increases here, or in other sense I will decrease the area of the plate. So why? Because capacitance is directly proportional to area and inversely proportional to distance. In order to increase its capacitance value, distance value should be decreased here, or in other sense I will decrease the, I will increase the area here. So if I decrease the area, capacitance value will get increased here, or if I increase the area, sorry here, so in order to get that capacitance value, I should decrease the distance here. If I decrease the distance, capacitance value will get increases here, or if I increase the area, capacitance value will get increases here. So look at here, capacitance value is independent on the charge here. So look at here, C naught is equal to epsilon naught A divided by D. So capacitance of a parallel plate capacitor value is independent on the charge on the plate A as well as on the plate B. It is independent on the charge on the plate as well as on the plate B here. So this is the required equation for capacitance of a parallel plate capacitor here. So now let me consider that. So here I consider that air as a dielectric medium. Instead of air, if I consider that any material medium I will place between the plate as well as between the plate A and B here. So if I place the dielectric medium between these two plates, then what about the capacitance value? After placing the dielectric medium, whether capacitance value will get increased or otherwise it will get decreased, I need to find out. So let me focus on, so what happens to the capacitance value if you place a dielectric medium? So in case of charge and field, already we come to know that. So between the two charge particle, if you place the dielectric medium, so remember the point. So between the charge particle, if you place the dielectric medium, its force value will get decreases here. So you are going to be write that equation for that. So in case of that Coulomb's law, so you will consider that equation here. So F is equal to what? 1 by 4 pi epsilon naught q1 into q2 divided by r square. So that is for free space. So if you consider that between the charge particle, if any dielectric medium is there means, so K you will consider. So force is inversely proportional to dielectric medium. It means that between the charge particle, if you place that any kind of dielectric medium, its force value should get decreases. So it is in case of charge and field. Now let me understand that between the plate A and plate B, if I place a dielectric medium, what about its capacitance value? So for that purpose, let me derive an expression for capacitance of parallel plate capacitor with dielectrics. So in case of that dielectric medium, what happens to the capacitance value? Whether its value will get decreased or whether its value will get increased, I need to understand here. Look at here, we got that equation for Capacitance of a parallel plate capacitor without dielectrics. What's the answer I get it here? Without dielectrics. So capacitance of a parallel plate capacitor without dielectrics, that is C naught is equal to epsilon naught A divided by D here. So now look at here. So in case of that charge and field, so we come to know that about that concept of force and field. So in case of force value, so force between the two charge particles is decreases if we place the dielectric medium. In the similar aspect, field value is also getting decreases if you place the charge particle, if you place the dielectric medium between the charge particles. So remember here, so in case of that electric field, so for example between the two plates, so between the plate A and plate B, so I am placing a dielectric medium, so entire thing is filled with the dielectric medium here. So let me take the dielectric medium here. So for example between the plate A and plate B, I will fill with the dielectric medium, so that dielectric medium value as a constant, so that value I will name it as a K here. So now in this situation, so electric field is present between the plate A and plate B. So between the plate A and plate B, I will place the dielectric medium. Then what about the electric field value if you place the dielectric medium between the plate? So electric field strength value will get decreases. So electric field between the plate after placing dielectric medium. So initial field is E naught I will consider. Without dielectrics, its electric field is E naught. Then E naught changes to that E naught by K times here. So electric field is inversely proportional to dielectric material here. So E is equal to E naught by K after placing a dielectric medium here. Why? Because its value will get decreases. Electric field lines value will get decreases if you place the dielectric medium between the plate A as well as between the plate A and B here. So now look at here. So if that field value is changes from E naught to E naught by K, then what about its potential? Potential is given by, so what is the relation between field and potential? So E is equal to what? So E is equal to V by D here. So E is equal to what? So E is equal to V by D here. If that electric field value changes from that E naught to E naught by K, so of course that, so field value changes from that E naught to E naught by K, means potential value is also changes from that V naught to V naught by K here. So potential value I will consider here. So why? Because field and potential is directly proportional here. So then potential value changes from V naught to V naught by K here. Why? Because field is inversely proportional to dielectric medium, means potential is also inversely proportional to dielectric medium here. So from the capacitance, new capacitance, so capacitance is given by, so shall I take this one, C is equal to Q by V naught here. So potential value is V naught. So if you place the dielectric medium, potential value changes from V naught to V naught by K. So shall I rewrite here? So Q divided by V naught by K here. So potential value changes from that V naught to V naught by K amount here. So let me rewrite this equation. C is equal to K into Q by V naught here. So what is the generalized formula for capacitance? So C is equal to Q by V. So air or dielectric. So air is act as a dielectric, means shall I take this one as a Q by V naught here? So C naught is equal to what? Q by V naught here. So let me look at here. So K into Q by V naught, shall I take it as a C naught here? So C is equal to K into C naught, where C naught represents what? Capacitance of parallel plate capacitor without dielectrics. K into, what's that C naught value here? Epsilon naught A divided by D. So look at here, new capacitance value after placing a dielectric medium. So look at here, so when you place the dielectric medium between the plate A and B, so in that situation, so its field value is decreases from E0 to E0 by K. If field value is decreases means I will come to know what about its potential value. So from the relation between field and potential, so V is directly proportional to E, or E is directly proportional to V here. So potential is also decreases from V0 to V0 by K here. So if the potential is decreases from V0 to V0 by K means, so what about that capacitance value here? So C is equal to Q by V0. So potentially changes from V0 to V0 by K here. So K into Q by V0 here. So what is that generalized equation for capacitance? C is equal to Q by V. So that C is equal to Q by V without any dielectrics. So that is C0. C0 is equal to Q by V0 here. So C is equal to K times into C0 here. So or in other sense, K is equal to what? C by C0 here. So what's the dielectric constant? K in this sense, the K is nothing but a dielectric constant. So that K is equal to C by C0 here. So then final equation, C is equal to K into epsilon naught A divided by D here. What's the conclusion I need to get it here? So C is equal to K into epsilon naught, so K into epsilon naught A divided by D. So C is directly proportional to K here. It means that in order to increase the capacitance value, so if I place the dielectric medium value, its capacitance value is getting increases. So how to increase the capacitance value in generally? So how will you increase the capacitance value? So in order to increase the capacitance value, area should be increased, distance should be get decreased, and so if you place the dielectric medium, its capacitance value should get increases here. So what's the equation for effect of dielectrics in case of a capacitance? So what's the effect of dielectrics here? So we are going to be understand that effect of dielectrics in case of capacitance. So effect of dielectrics. So how it will affect to the capacitance here? So whenever you place the dielectric medium between the capacitance or between the plate of the capacitance, so its capacitance value will get increases here. So look at here, if you place the dielectric medium between the plates, its capacitance value will get increases here. So hope you are understanding these things. Remaining